Hi everyone. Welcome to this MeaningCloud webinar. Today we will be talking about text analytics, specifically text classification or text categorization. We'll be describing some categorization scenarios which are very complex and where things can go terribly wrong, and we will be presenting some new approaches and tools that hopefully will help you cope with these scenarios. First of all, some introductions. My name's Antonio. I work for marketing in MeaningCloud, and we are a text analytics vendor, as I will explain to you in a few minutes. And we welcome your participation during this webinar. You have a couple options. At any time during the webinar, you can send us your comments and your question through the chat feature of your GoToWebinar panel, and we'll try to answer those as they arrive. And later during the Q&A time, we'll be answering the most relevant or frequent comments. And during the Q&A time also, you can ask your question by voice. And to do so, you just need to press the little hand button that you see there, and we'll enable your mic and you'll be able to ask your question. As always, we are recording this webinar and we will be publishing all the contents, the recording, the presentation, the data sets for the use case in our blog. So stay tuned to our email and blog. So why this webinar? And the reason is something that we found when we try develop text analytics solution for you, for our customers, and also some of our customers who are beginning to develop their own text analytics solutions are finding, and is that text categorization can be very difficult. There are very complex scenarios with many moving parts, with requirements in evolution, with very dynamic contents, which are very difficult to cope with. And so in this webinar, we are presenting a new approach based on semantic analysis of the text, in understanding the meaning of the text, and that we hope will help you to develop solution for this kind of scenarios. So we plan to cover this agenda. First of all, we'll talk about real-world categorization scenarios in which you apply typical machine learning technologies to develop categorization models. We'll see the limitation of this approach in difficult scenarios, and then we present our solution based on an API that we provide that is called deep categorization, and a new customization tool for this API. And we'll go through a case study and develop a real categorization model so that you can understand and get a flavor of how the tools work. And then we'll describe some advanced processes for an agile development of categorization models, some very advanced scenarios that makes deep learning technologies and semantic analysis technologies to get the best of this world. And finally, we'll be open to your questions. So let's get started talking about text categorization in a perfect world. Essentially, the process, as you probably know, is first I need to use some training text to train a model using typical supervised learning algorithms. And after that, you generate your model, and then you use your model with machine learning categorization engine, so that if you send an input text, you can obtain the categories that are more relevant to this text. And this will be the execution part if you want. Interesting to note here is when I say here a training test, this is not something that falls into our lap. Essentially, unless you are a Facebook, for example, and you have millions of users willing to tag content for free for you, in a typical business situation, you'll have to devote valuable human resources to manually tag this text so that you can feed your machine learning algorithms. So instead of training tests, we should write here human tagging text, because this is the result of a costly human activity. So what are the advantages and the limitations of this approach? Essentially, building models with machine learning is relatively easy and fast, obviously, provided that you have a sufficient training set. And this implies also that these models are relatively easy to adapt to new domains. And on the cons part, it's necessary to have available enough training data, and also these models are black box models, in the sense that you don't know what is happening under the hood. You don't know why a certain category is assigned to a given text, and it's relatively difficult to add new knowledge into this model. We can say it in other words, as this model has a high inertia, if you want, in the sense that once this model have been trained and you want to adapt to a new category or improve precision or refine the model in some way, you need a substantial retraining of the model to change the behavior. And also, these models don't justify the categorization result. You don't know why the text has been assigned to a certain category. But as I mentioned, there are difficult scenarios, and I would suggest you to ask yourself if you have ever found this kind of situation. For example, you're working with your customer, either internal or external, and they say, okay, this is our new taxonomy or new set of categories, but it can still be improved, meaning this is our taxonomy today, but maybe tomorrow it will be different. Or, for example, training tests, that's funny, but we don't have tag tests because the taxonomy is new or whatever reason. So you don't have training tests to train your system. Or, for example, requirements that have to do with the ambiguity of natural language, and where you need a high precision to discriminate among categories. For example, it's important to differentiate Washington, the city, from Washington, the surname, or Washington, maybe the football team or whatever, because these different meanings imply a different category. Or, for example, you have your model working, and from one day to another, this model is based on the product names of the company, the brands, the customer, the competitors, whatever, and the situation changes and you need to change the names of all your products, all your plans, all your promotions for tomorrow. So maybe you have found this situation yourselves, but this is what I have taken us to talk about wicked categorization problems. When you have categories that are not well defined or are evolving, or when you do not have an adequate training corpus, on when you need a great precision to discriminate among categories, or when context in general is very dynamic. So this, in our experience, these wicked categorization problems involve very huge costs in development, in use and exploitation of the models, and in evolution of the models, because it's difficult to do this using typical machine learning technologies. So all of these take us to new needs in terms of way of doing things. We need new processes that enable us to rapidly generate a new categorization model, to easily incorporate domain about the knowledge in a very agile and abstract way, to configure and refine your models in a very powerful way, so that you can enhance precision, enhance recall, adapt to your environment, etc. And also a process that enables you to create quality assurance practices, so that you can perform a continuous improvement of your models. So this is what we call Agile text analytics, or Agile categorization, and essentially it consists of an inherently iterative and incremental process for the continuous improvement of your categorization models. So how we solve it? Okay, so for those of you who don't know us, MeaningCloud is an advanced text analytics vendor. We like to say we do semantic analysis on the text, and we have deployed our product, which essentially is a set of standard APIs that perform text analytics functions. And these are available both as a service in the cloud, or for on-premises deployment if you want. And you can, by the way, you can register and experiment with the system for free, because we have a very generous free plan. So I encourage you to go to meaningcloud.com and register. And the way we cope with these wicked categorization problems is based on an API that we provide, and which is called deep categorization. And as the name implies, it's a categorization API. You send an input text, and it uses a model to return the applicable categories. But it uses a technology which is not the typical machine learning, but is based on the analysis of the meaning of the text. MeaningCloud performs a very deep morphosyntactic and semantic analysis of the text. It discovers the structure of text. It disambiguates words depending on the context to associate very precise meaning to these words. And this deep categorization API uses all this meaning that we extract to take decisions about categorization. This API was generally available since last year or so, but so far you were only enabled to use it with predefined models, meaning categorization models that we build and we provide as part of our standard products. For example, we have an IAB version 2 categorization model for categorizing web content. And this is a model which is included for free in all of our plans with the deep categorization API. And we also have what we call vertical packs, which are predefined solutions for certain application domains. And these solutions include deep categorization models. And some of these packs are ones for the analysis of the voice of the customer, and this implies analyzing the unstructured feedback that customers send us through different channels like social media or the contact center or surveys. And another one is the voice of the employee analysis vertical pack, and this is for the analysis of employee feedback. And we also have a vertical pack for intention analysis. And this pack identifies the stage in the customer journey where a particular user is, depending on their comments. So you can identify if the user is looking for information or is evaluating a product and is looking for very specific information, or buying the product or using the product, or looking for requests or complaining about the product or recommending the product. So these are the situations that the intention analysis can detect. So these are predefined models that we've been provided for several months now. What has changed now is that we have the possibility to customize the categorization for your needs, or develop your own domain-specific categorization models. And for that, we have recently released a customization tool for deep categorization that enabled you to create your personal models. And after that, obviously, you can use the deep categorization APIs to categorize your input text according to your defined categories. And the interesting thing to note here is that you don't need a huge amount of training text. Obviously, tag tests always help in terms of examples, or because helps you understand the meaning of the categories or understand your domain. But essentially, you are using domain knowledge that human experts or human users have, and that they need to codify into the model using very powerful rules. So essentially, how the custom categorization model work is you use all these morphosyntactic and semantic information that we extract from text. We divide text into words, we normalize the text, we standardize text, we correct mistakes, we discover the grammatical structure, disambiguate and identify a specific meaning of words within the context. And after you have that, you apply very advanced pattern matching to see if certain rules that you have written are triggered. And as I mentioned, these rules are generally human defined, but as I will explain you later, we are exploring ways to also automatically generate these rules. So I don't need to mention that this is a very difficult endeavor because we have all the ambiguity of language. We have circumstances where you need to categorize with different categories text which are very similar, like in this case you have here as an example. If you need to detect when a person has purchased an iPhone, only the second sentence is valid. The first one or third one, even if are very similar, are not applicable to this category. So this is the things that we need to resolve, and essentially the language needs to allows us to define rules and apply certain categories, but obviously what we need here is not the typical low-level rule language, but something which is more powerful, more abstract, that performs better. So we need to have several features within this language. We need to have modularity and the ability to reuse components so that the language is very productive and structured. We need very powerful operators to create your rules. Obviously, you need to use all this semantic information. So we need to you need ways to access and use all this data, and obviously we have a high level of abstraction to do things in a very powerful way and not needing to write very low level rules. So just to give you a flavor of the semantic rule language, let me describe a few examples for you. The language allows you to use literals and regular expressions and multi-word phrases, and gives you the typical logical operators and proximity operators to detect when a specific expression is less than 2 or 3 or whatever words away from another expression. We have lemmatization capabilities and the ability to use the grammatical function of words within the text. For example, you see here the difference between the lemma of produce and the specific form produces. These are differently treated in the rules. And here you have an example that deals with a category about innovation. So we need to detect when things like new product or new service or new process or new processes appear. And we can express this kind of thing like here with this L at sign, which express a lemma, and this at n sign, which express that the word is functioning as a noun instead of a verb, which is possible in the English language. So you see the power of this kind of expression. In this case, new and these other words need to appear at a distance less than 4 words. Also, we have macros that help you define modules that can be used in different rules, in different categories, like in this case, pet, which is equivalent to dog or cat or rabbit or turtle. And we also have very powerful ways to embed the semantic information that we extract. For example, this is a rule to detect when you are talking about Bank of America competitors, meaning any bank which is not Bank of America. And the way we have to describe and express that in a rule is, like in this case, we have, if you find something which is an organization of type company, of type financial company, of type banking company, and this particular instance appearing is not entity Bank of America, you can surely categorize this text as Bank of America competitor. Or if you find something which is a living thing of type animal, except the animals that you have previously included in your pet macro, you can assign the category of non-pet animal. Also, we have the possibility to include geographical information, like in this case, this expresses appearances of locations that belong to Canada. So any thing which is mentioned and is a place in Canada can be tagged as something related to Canada. And also, what gives you a high abstraction level and high modularity is the possibility not only, obviously, to include rules to define categories, but to use categories within rules. So in this case, for example, if a text has been classified as speed agility and also classified as channel app, you can assign it the new category speed agility with app, and maybe even make this new category prevail instead of the two previous one. And also the language is able to cope with spelling mistakes. Like, for example, you write Bank of America, it identifies, depending on the content that we are talking about, Bank of America. So let's go very quickly to see a short example. This will be focused on a scenario that I'm sure many of you know, which have to do with contact center and the necessity to categorize tickets in the contact center. I'm going to present an example based on a contact center that we know very well, which is MeaningCloud. Maybe some of you are users of this or of our support line. And the fact is that you send us messages about different things, and let's say we need to categorize that according to these categories. Like, one of them is related to problems or issues with the APIs. Another one is related to problems with the integrations that include the product, like the Excel add-in or the Rapid Miner extension or the Zapier app or whatever. We also have another category related to problems with the website. And by that, I mean problems when registering to the product or receiving the validation email or charging or invoicing, etc. And let's say you also have a category related with commercial information, like prices or condition of the service. And let's say we also have a default category like information request, where you can put every comment that does not belong to these previous categories. So we are going to do is to use a ticket sample like the one I have here. Let me show you the real thing. So this is the sample of tickets with subject description. Previously tagged these tickets for informative purposes, and also aggregated the subject and description into a unique column to have more information. And I'm going to use this information to generate a categorization model using the deep categorization customization tool. So let me take you to the real product. Okay, this is our customization page. We have different tools for creating dictionaries and sentiment models, etc. And this is the deep categorization model creation tools that I'm going to use. Okay, so essentially I'm going to use to create a new model. Let's call it webinar. Okay, I'm going to select the English language, and I'm going to create the model. Okay, it offers me an empty model with no category, and I'm going to create a category for things related to problems with the registration, etc. process. That, if you remember, we call that BR web. Okay. Book report web. So I create this category. That's it. And Personally, it's an empty category. It doesn't include any rule. So let's begin by figuring out some real cases and seeing how we can develop this model. So the process I'm going to follow is to first write some rules based on a basic knowledge of the categories. Then I'll use some advanced features to use the semantic information to multiply the accuracy of the model. And then I'll show you how to apply iterative and incremental development to refine and adapt to dynamic scenarios like the ones we are dealing with today. So first of all, let's focus on a very simple scenario, and has to do with the category I've just created, the bug report web category, specifically with, as I mentioned, the validation email problems. So I'm trying to detect messages from you in which you state things like, I didn't receive my validation email, or I'm still waiting for the confirmation email. But be careful, because expressions like I'm waiting on confirmation that you have received my email would not be relevant for this category, because it expresses a different thing. So based on the knowledge of the domain and my knowledge of the language, I can begin to write rules like this one, which is very simple, but very powerful. Because you see in this simple expressions, we have many advanced features, like by default, if you write verbs like this, you're expressing the lemma, so you are covering expressions like I didn't receive, I'm waiting, etc., etc. And also, if you express this mail thing, you're using regular expressions to express things like mail or email or this other way of writing in, etc. And if you use these quotation marks, you are using literal multi-word expressions like validation mail, confirmation email, etc., etc. So you, in this simple sentence, you cover a broad variety of expressions that have to do with problems in your validation email. So let me go and create this rule. Let me copy from here so that I can go faster and avoid typing mistakes. So I'm going to create this rule, which I'm going to call validation email. I'm giving it a priority of 1, meaning these are evaluating first. And also I need to specify a weight which express the influence on the relevance of the text within the rule, within the category, sorry. So I can paste here the definition that I just wrote. Okay. So let's create a rule. Apparently it's been created successfully, and I save the category. And let's see what happens. So let us check if this works. Okay, so I'm using the test console that we have for every MeaningCloud API, and it takes me to, I'm sure many of you have seen something similar for other APIs. This screen enables us to launch calls to this specific API, the categorization, using the specific model that we are creating. Okay, so let me select, okay, perfect. So let me paste one of the examples I showed you earlier. For example, I'm still waiting for the confirmation email. Okay, so let's see what happens. Okay, you see it has assigned the bug report web category, and we can go deeper into the analysis and see the rule has been triggered because it has detected this verbal form, the appearance of confirmation email, and this all match with this specific rule. Along with this formatted output, by default, you also have the JSON output that you can use within your applications to process the results of MeaningCloud. Okay, so we have created our first rule in our first category. Let's quickly develop another category. For example, if you remember, I mentioned a category called information request. That was the default category. Okay, let's information request, and let's call it. If I click here, the rule is created. I especially don't need to include any rule in this category because this is the category by default, and anything which is not categorized in the other categories will be categorized in this specific category. Okay, so let's move on and see how I can do sophisticated things in terms of including semantic information in your rules. And I'm going to focus on these two other categories, which are related to bugs or errors or issues or problems with the APIs or the integration product. So I need to detect things like I'm having issues with the sentiment API or this other expression about the voice of the employee plugin, etc. So we need to be able to detect mentions of MeaningCloud products in a context that talk about error, bug, issue, problem, whatever. So we need to find a powerful way to express mentions of APIs or mentions of MeaningCloud integration product. So the way to do this is to embed some semantic information into your model, and this is done by using a dictionary. A dictionary, so many of you know it, is the way in which we can create our own entities and our own ontologies within our own category concepts within MeaningCloud and associate a specific semantic information for them. And I'm going to create this dictionary and embed that into my model so that I can write rules that use the semantic information within this dictionary. And this dictionary obviously will consist of all the MeaningCloud APIs and all the MeaningCloud integrations, like the one you have listed here. And in that way, once I have these entities and concepts, I can write rules like this one. So if I found something which is a API product within MeaningCloud, an error, bug, issue, problem, etc., this will be an API issue. Or if I detect something which is a product of type integration and error, bug, issue, problem, whatever, it will be related to the bug integration category. So let me show you how to implement this into the product. First of all, I'm going to show you the dictionary. I don't have time to create a dictionary, but I'll show you how this structure. I'm sure many of you are familiar with this functionality. This is the way in which you manage a dictionary within MeaningCloud. This is a list of entities that are either API products or integration products. And these entities are defined by several components, like, for example, its aliases, like, for example, in this case, the sentiment analysis typically receives many other names, and people refers to it as sentiment, for example, the sentiment API. So we need to be able to detect that. And also very important is the semantic information associated with this specific entity, which is a product of type API. Okay, so I can again go to my model, okay, and create a new category, like as I mentioned, bug report API, and give it a label. Okay, this is not the default category, which I have already created, and I can go to category and write this specific rule. So I'm going to call it API error. Okay, I give it a priority of 1, a weight of 1 again, and I'm going to, let me paste because it will be easier. This rule that uses the, as I mentioned, the semantic information, if I found anything which is a mention of a product of type API, etc., etc. So I create the rule, okay, success, and I save my category. Let's test it. Again, I'm using one of the sentences I created. So if I go and paste my comment here, I'm having issues with the sentiment API. Let's see what happens. I'm using my webinar model again. Oops. So I forgot to do something. Yes, first of all, I need to include my dictionary, I'm sorry, into the model. Okay, that's what I've missed. And then once I embedded my dictionary into the model, yes, you see, I'm analyzing according to the semantic information in my dictionary, and you see it has detected the sentiment mention, the issue mention, and the rule that has been triggered. This is very useful to debug or models. Another, let me show you another tool which is very useful for debugging models, which is what we call test parsing, which gives you the semantic information that MeaningCloud is able to detect within the text and that you can use within your rules. So if I send, you see, along with all these general terms and words, it has detected things like sentiment analysis as a product of type API, etc., etc. So let me show you a few other things, a couple of additional things. One of them is the ability to define macros. Like, for example, in this case, you remember we are using error, issue, problem in different rules, so we can define that as a macro, which is called error. Or, for example, mention of representative, an agent, or someone, or engineer are equivalent to agent. And we can rewrite my previous rules. This is the one I have created, but instead of always expanding the list of terms that can be included there, I can use this component of the error macro, and makes me more productive and my model much more structured. Another thing that I can use is a very advanced feature, as I mentioned earlier, is the capability to use categories within rules. So in this particular case, there are cases where there are conflicts between categories. In this particular example, it mentions product, it mentions integration, so you typically could assign both of these categories to the text. But what we have found is that in this situation, people is essentially talking about problems with integrations, not with APIs. So the correct categorization will be like that. So what we can define, it's rules that mention that if you can assign this category to a text and this other category, you can exclude this API category, but because the relevant category is in fact bug report integration. Okay, so let me show you very quickly how this is implemented into the product. Let me go to, I have pre-cook complete model for this specific case. You see here all the categories that I wanted to create. So if I go to the bug report APIs, you see it has a particular rule called API redundancy, which expresses that if I can assign this category and this other category, exclude the category I'm in, which is bug report APIs, because the category that needs to prevail is bug report integrations. And finally, another feature of the language that I wanted to show you have to do with dynamic situations. So imagine I need to change my product, or in our case, imagine we launch a new API, which in fact we'll be doing in some months, hopefully, which will be called Insight Engine. So imagine that if I did not have all this dictionary arrangement, maybe I would need to include this new definition in all the rules, etc. But in our case, because of the modularity and the abstraction of our approach, I only need to include Insight Engine in my dictionary, and automatically all these modifications are propagated to the model, and from that very moment I'm able to detect this new product in my model. So imagine, for example, if I go to my dictionary, you see Insight Engine is not included here, but I'm going to add this new entity called the Insight Engine of type entity, and most importantly, it is a product of type API. So I'm going to edit it, because typically people refers to the Insight Engine as Insight Extractor. So let me save that, and without modifying the model, I'm here with my webinar model. Okay, let's simply test. I'm going to use this phrase like I'm having issues with the Insight structure. Using the webinar model. Okay, you see I'm now able to detect this new product or any new product that I have created, and I have implemented just by modifying and extending my dictionary. So hopefully you've been able to see the capabilities of the rule language. And just to summarize some of the things we'll be talking about, on the pro side of the semantic rule approach, this is a white box model, meaning you can easily see how it's working and modify and add new knowledge. It has a very low inertia because you can include new rules, and with a simple route totally change the behavior of the model. You can very easily correct errors or increase precision or recall, and with only adding more rules, you can increase the precision and recall as much as you want. Also, does not require tagging training corpus, because you can begin to work with basic knowledge, and the of the domain, and also it justifies your categorization results. This is very useful for debugging purposes. On the con side, you see development requires some effort in the definition of rules, but obviously this is less effort than manually tagging a collection of, say, 1 million documents, okay? And also, well, as a consequence, adaptation to new domains is relatively expensive. I just wanted to show you how the model works. You see here, this is my set of comments, just to show you how the Excel plugin works. So let me use the Categorization API. Let me use. Okay. English. I'm going to use not the partial model webinar that I have created, but the whole support ticket categorization model. Let's go and analyze. So the plugin sends the comments to the deep categorization API, and the API returns the code identifier and the category label. Okay, you see here the comments have been categorized according to my specific categories. So this is a very simple way to prototype and create solution based on MeaningCloud APIs. So let's move forward to the final part of the presentation that have to do with this complex and sophisticated agile development process that include several technologies. And the first one I'd like to discuss is maybe many of you are familiar with another API that we have for text classification that has that precise name, text classification API, that is based not on semantic rule, but on machine learning rules, and also an additional layer of basic rules. So the question is when to use one or to use the other. So here you have a summary. The answer will be if you have a well-defined and fixed categories, or you have very big models like tens of thousands of categories, because machine learning models tend to be more computationally efficient and faster. And also you have plenty of training texts are available and relatively static scenario. You still can use, and in fact, we recommend that you use text classification API. But if you have these weak categorization scenarios with badly defined or evolving categories, or models that are not too expensive, or you don't have enough training text, or you need high precision to discriminate, or a dynamic scenario, etc., etc., I would recommend that you explore deep categorization API. So let's now talk about how you can combine sophisticated machine learning technologies and deep categorization and semantic analysis technologies to get a very agile and very powerful categorization development process. So this is what been discussing so far: the deep categorization API, the ability to create rule models in a iterative way, writing and modifying and adding rules. But in situations where you have training tests, what you can do is create also a machine learn based categorization model. This can be done, for example, using deep learning technologies that I'm sure many of you have heard of, that gives you a high accuracy in the categorization. So you can do is generate this machine learning based model and use that to analyze text and create some, if you want, preliminary categories. And after that, once you have these preliminary categories, feed that along with your input text to the deep categorization API and refine and improve your categorization using the deep categorization. So just to clarify, you're using deep learning or machine learning to do a preliminary categorization, and after that to elaborate this categorization using the deep categorization tools. So what we get here is the best of these two worlds, the fast model development and very high precision from the very beginning, and also adding the transparency and the refinement adaptation capabilities that the deep categorization technology adds. This will be one approach, and the other approach is essentially based on the deep categorization APIs, meaning the categories are only generated by deep categorization, not with machine learning, but you are using machine learning to automate and optimize the rule model generation process. So for example, first of all, you define a quality assurance infrastructure so that you can use the result of your categorization and some training tests to see some quality metrics and see how you are evolving. And also you can use some machine learning to generate rules, to at least build a version 1 of your rule model, so that after you have this version 1, you can use your customization tool to evolve and refine this preliminary model. And also, what you can do is use some rule expansion technology that we are experimenting with. This is machine learning related technology, for example, what is called word embeddings, that enable you to detect synonyms or related terms to a specific expressions that enable you to expand your rules. So to make your rules more powerful, more precise, to have more recall, etc. So you can use this other machine learning technology to automate the creation of your rule-based models. And again, the categorization is only made with the deep categorization technology. So what we have here is a fast development of your rule model using this automation thing, and also a support using this rule expansion technology of your iterative refining process. Finally, I would like to cover a couple of examples that we made for real customers. One of them has to do with call center analysis in a telco company that needed to analyze some million calls per month. And it was a very difficult scenario in which we have a complex multidimensional model with thousands of categories and very difficult to discriminate between categories, and most importantly, a very short time to develop the solution because of contractual limitations. And we were able to generate a sophisticated model that used an intensive use of macros, of virtual categories that you could use inside some rules to define some other categories. And we use the words embedding capability to expand the rules and to find synonyms and related terms. And we were able to define a model with a few thousand rules and several hundred macros in a very short time frame and be able to deliver a very high quality. Another use case that I'd like to highlight is in a bank. They needed to analyze emails to do automatic routing. And then it was a multidimensional model, again, in 3 languages, also with a very high semantic overlap. And we were able to, using many product and service dictionaries, being able to generate different models for each language with a few hundred rules for each language, and also deliver high quality in terms of precision and recall. So essentially that's it. As a conclusion, to let you know that these wicked text categorization problems really happen. And if you haven't bumped into this kind of scenario, you can consider yourself very fortunate. But if you continue to develop solutions for text categorization, I can assure you that you find this type of scenarios. So hopefully after my presentation, you'll be able to recognize them, to assess them, and be able to foresee what can possibly go wrong. And the second conclusion would be that we have a different approach based on the understanding of the meaning of the text that enables this agile development process, and we suggest you that you give it a try and see if it can help you in your wicked text categorization problem. So I think we're running out of time, so hopefully we have a few minutes for your questions. Anybody would like to ask something? Okay. So let me just answer a couple of questions that people have asked. One of them is about the availability of all the solutions that I mentioned. So essentially, deep categorization API is available. The customization tool is available. The vertical packs based on deep categorization are available already. And the development process based on deep categorization is available. And if you want to mix deep learning with deep categorization or some other machine learning tools with our deep categorization technology, we have that in place in several customers in on-premises deployment. Hopefully it will be generally available in the coming months, but if you need to apply those right now, just give us a call and see what we can do for you. And second very practical question is, how much does it cost? So to summarize what is generally available today, deep categorization is API. API is included at no additional cost with your MeaningCloud plans, even the free plan. And the customization tool also is included at no cost with your MeaningCloud plans. And the vertical packs are premium products and are available for you for a very modest monthly fee. So I think we have answered the most frequent questions. So I think we're running out of time. If you don't have any other questions, thank you everyone for your attendance, and hope to talk to you soon, and have a great day.